Okay, so circles, angles, arcs, number 3. Are you ready? Did you take notes for today?
I'm trying.
Okay. So what's the word for today? Today's word is secant. Everybody say secant.
Secant.
S-E-C-A-N-T, a secant. So what's a secant? Here is a circle. All right? This line that goes from one side of the circle through the other and out, this is a secant. There you go. Line through a circle, not through the center, although I guess it potentially could be. But generally speaking, not through the center, from one side through the other and out. And what we often do is connect them. We do 2 secants connected at the point out there to form an angle. So here's the second secant. Like that. Did I draw it straight? Not too good, not too bad. Once we draw 2 secants, now a bunch of awesome relationships are formed. Okay, so what word did we learn last week? We learned, well, 2 weeks ago now, arcs. Remember arc? Everybody say arc.
Arc.
Arc. I said it funny too, arc. I said it like a pirate, arc. Anyway, forget that. Okay, so what's an arc? What is an arc? Okay, draw an arc in the air with your finger. So interestingly enough, a lot of times I say, what is something? And you guys just look at me. But then I say, draw it in the air, and you draw it fine. And I would say perfectly, because I can't tell how perfect or not perfect that is. So you draw it perfectly in the air, right? Yes, that's an arc. It's a portion of a circle, right? So the outside of a circle's here. That's an arc, and this is an arc. Now, these are arcs out here also, but we're not interested in them right now. We're interested in this arc, this one here. Here's the, let's say this is the center of the circle. We're also interested in this angle right here. What's an angle? Okay, use your fingers, hold up a symbol of what an angle is. Yes?
It's like a line. It's a 180 degree.
Nice.
Or 9.
Yes.
45.
Yes. Right? Some of you are going like this, some of you are going like this, or anything, or one person went like that, right? Interesting. 180 degree angle, right? It's called a straight angle. Yes, you can go like that, right? Do you remember that song about somebody once told me the world was going to roll me? Yeah. Right? So is that an angle? That's an angle, right? Your finger and your thumb in the shape of an L on my forehead. Okay, forget that. So that's an angle. But what is an angle? What word do I want you to remember for what an angle is?
Rotation.
Yes, I really want the word. Everybody say rotation. Because how do you know? Okay, here I am. I'm looking this way. And I do this. What would you say has happened?
You rotate.
It's a rotation. How far?
180.
180, right? So the 180 is a number of degrees. Degrees is the unit of measure. So we can measure my rotation, right? If I rotate this far, how far is it?
90.
Right? So the 90 is the amount of degrees, the measure of rotation. So an angle, when you're looking here, you're looking at how far does this rotate. When I go from here to here, what's the rotation in there? That's the angle you're talking about. And that measure is what we're always talking about angles. So now arcs line up here too. This arc can be connected to the center. That's a rotation, that arc there. This is a rotation here. How far is that, right? And so we're measuring these different arcs and the angle at the end. So if we call this arc A, this arc here is going to be called arc A, this is arc B, and this angle is going to be called C. These are related by the following equation. C equals A, the larger arc, minus the smaller arc, divided by 2. Everybody go, oh. That's so awesome when you guys do that. Can you imagine if I ask a class to do that and nobody does it?
That's sad.
Do you think that's ever happened before?
Definitely.
Which is just as funny as when students do it. It's equally funny when they all go, no, I'm not doing that. And then some classes will be like they won't do that, but they'll do the hands. Very interesting. Okay, so say this out here. Let's give it some measures and just run through. if this is 200 degrees out here, so 200 degrees is the length or measure of this arc. This one is 50 degrees in here. That's the measure of this arc. Like if you rotated, it would be 50-degree rotation there. We're wondering how much C is. So we'd take A at 200. We'd subtract out 50, put it in parentheses because you're going to do that first, and then divide it by 2. So C is going to be 200 minus 50 is 150 divided by 2. The measure of this angle or rotation up here is 75 degrees. Pretty cool? Interestingly enough, also the lengths of the segments of the secant are related. So take a second circle and do 2 secants again. And now we're going to talk about not the arcs and the measures of rotation, but the lengths of the segments. Let's see, let me label it the same way. A, B, C, D. I call this segment in here A, segment A. This one's segment B. This segment C, and this segment D. So segment means this piece of this secant. D means this piece of this secant. B is this piece of this secant. A is this piece of that secant. 2 secants divided into two segments each. Fair enough? So these are related by this relationship. Again, I'm going to write it like I did. The outside component or segment, B, times the whole length, A plus B, is equal to the outside segment of the other secant, D, times its total length, C plus D. Okay, kind of fun. And then let's plug in an example from the notes. And I'm going to use this one just like I did before. Let's say that A for us, this is an X right here. We don't know. We don't know the length of this measure, A. We'll call it X, or it could just remain A, the variable. This is 3 long out here. This is 4, C is 4 long. D is, how long did I say? 2 long. 2 units long, not too long. If I say it's too long, it sounds like it's too long. But it's 2 units long. Okay, fair enough. All right. So B equals 3. So we're going to put a 3 here. We're going to call this an X. We'll put that in for A because we don't know. And then it's being added back to B because X plus 3 is the total length of this secant. D in this case is 2. C is 4 plus the 2 again. 4 plus 2. What is 4 plus 2? 6 times 2. If we distribute this here, 3 times the x is 3x. Plus 3 times 3 is 9. 2 times 6 is 12. 3x plus 9 is 12. Subtract the 9 from both sides. Gone. And 12 minus 9 is 3. So 3x equals 3. Divide both sides by 3. And x equals 1. So this length of this piece up here would be 1 long. 1 unit. Okay. What else do we say in the notes? So I think what we like in geometry about these, they're very sort of, I want to say simple. They're simple and fun relationships that allow us to then go, given this one and this one, you know, find the value of this one. Given whatever one of all 3 of these and then missing 1, find the 4th. Right? But that's it. This is a pretty straightforward presentation of secants dealing with the arcs and the lengths or segments of the secant. That's it. I think that's all that's in the notes. It goes back through radius, diameter, chord, and that's it.